Hello everyone, and welcome to CodeZultant channel. Today, we will be continuing our discussion on branch circuit calculations, focusing on sizing electric ranges, electric clothes dryers, water heaters, motors, and air conditioning units. This is part 2 of our discussion on this topic, and we hope to provide valuable insights and information for fellow practitioners, engineers, electricians, and future engineers. In the first part of our branch circuit calculations, we covered the code rules regarding general lighting loads specified in section 2.20.2.3. This section includes receptacle outlets in general areas such as living rooms, bedrooms, hallways, and similar areas, as well as bathroom circuits, laundry circuits, outdoor areas, garages, basements, and accessory buildings and lightings. It's important to note that no additional load calculation is required for these outlets. When it comes to small appliance circuits installed in areas like kitchens, pantries, breakfast rooms, and similar spaces, they must be calculated at a minimum of 1500 volt amperes. The 180 volt amperes rating for each receptacle outlet does not apply to all types of dwelling units. Continuing with part 2 of our topic, all fastened in place appliances in the layout shown must be calculated. These include the 4 kilowatts clothes dryer, 6 kilowatts electric range, air conditioning units, 4.5 kilowatts water heater, and motor loads. Here's a summary of the branch circuits based on the layout of the sample project. The branch circuits for general lighting loads and receptacle outlets have been determined as shown in circuits 1 to 8. Now, we need to determine the load for the remaining individual branch circuits. What are the rules for individual branch circuits? Sections 4.22.2.1. A. Individual circuits, first and second paragraphs, specify that the rating of an individual branch circuit must be equal to or greater than the marked rating of the appliance or the marked rating of an appliance with combined loads, as outlined in section 4.22.5.3. Additionally, for motor-operated appliances that do not have a marked rating, the rating of an individual branch circuit must comply with part 4.30.2. If an appliance is a continuous load other than a motor-operated appliance, the branch circuit rating must not be lower than 125% of the marked rating if the branch circuit device and its assembly are listed for continuous loading at 100% of its rating, not less than 100% of the marked rating. Branch circuits and branch circuit conductors for household ranges and cooking appliances may follow Table 2.20.3.16 and must be sized in accordance with 2.10.2.1a3. Let's apply section 4.22.2.1. To our project, specifically for a 4.5 kilowatts storage type water heater. As per the section, if the capacity of the storage type water heater in our sample project is 450 liter or less, it is considered a continuous load as per section 4.22.2.4. Therefore, the minimum conductor ampacity must be calculated by dividing 4500 watts by 230 volts and then multiplying by 1.25 to account for the continuous load. This results in a minimum conductor ampacity of 24.57 amperes. According to Table 3.10.2.6b16, a suitable conductor size is 5.5 square millimeters. The branch circuit protection for appliances is outlined in section 4.22.2.2, overcurrent protection. In subsection 4.22.2.2a, it is stated that if an appliance has a marked protective device rating, the branch circuit overcurrent device rating must not exceed the marked protective device rating for the appliance. This section applies to appliances that are already available for installation. However, if the appliance is not yet available, section 4.22.2.2e to be followed. Section 4.22.2.2e pertains to single non-motor operated appliances. If the branch circuit supplies a single non-motor operated appliance, the overcurrent protection rating must comply with the following requirements. 1. It must not exceed the rating marked on the appliance. 2. It must not exceed 20 amperes if the overcurrent protection rating is not marked and the appliance is rated 13.3 amperes or less. Or 3. It must not exceed 150% of the appliance's rated current if the overcurrent protection rating is not marked and the appliance is rated over 13.3 amperes. If 150% of the appliance's rating does not correspond to a standard overcurrent device ampere rating, the next higher standard rating is permitted. For a 4.5 kilowatts water heater, The branch circuit protection must be calculated as follows. 4,500 watts divided by 230 volts equals 19.57 amperes. According to paragraph 3 of section 4.22.2.2e, the maximum branch circuit protection must not exceed 150% of the appliance's rated current. Therefore, the maximum branch circuit protection for this water heater is 19.57 amperes multiplied by 1.5, which equals 29.57 amperes. Since 29.57 amperes does not correspond to a standard overcurrent device ampere rating, the next higher standard rating of 30 amperes may be used. For equipment grounding conductor, use 5.5 square millimeters. What are the rules for sizing the electric clothes dryer and electric range branch circuits? Under section 2.20.2.5, other loads, all occupancies. Paragraph B states that electric dryers and electric cooking appliances in dwelling units. Load calculations shall be permitted as specified in 2.20.3.15 for electric dryers, and in 2.20.3.16 for electric ranges and other cooking appliances. The load requirement for an electric dryer shall have a minimum load of 5,000 volt amperes or the nameplate rating, whichever is the larger as stated in section 2.20.3.15. While for the electric cooking appliance for dwelling units shall be calculated based on table 2.20.3.16 if the rating exceeds 1.75 kilowatts. As stated in table note 4, the branch circuit load for one wall-mounted oven or one counter-mounted cooking unit shall be the nameplate rating of the appliance. Since the rating of the electric clothes dryer for the sample project is only 4 kilowatts, therefore the branch circuit loads for a dryer at circuit 9 shall be 5,000 volt amperes, while for the electric cooker shall be the nameplate rating, which is 6,000 kilowatts. How about their branch circuit conductors and overcurrent protective device? To determine the branch circuit conductor of household ranges and cooking appliances, we can refer to section 2.10.2.2, 8.3. This section states that the conductor must have an ampacity that is not less than the rating of the branch circuit and not less than the maximum load to be served. For ranges with a rating of 8.75 kilowatts or more, the minimum branch circuit rating shall be 40 amperes. Since the rating of the electric range is 6,000 volt amperes, the minimum ampacity of the conductor shall be 26.08 amperes. According to table 3.10.2.6b16, the suitable conductor size is 5.5 square millimeters. Use 30 amperes for branch circuit protection and 5.5 square millimeter for equipment grounding conductor. While for the electric clothes dryer, we can refer to section 2.10.2.2, 8.4. Other loads. Branch circuit conductors that supply loads other than those specified in 2.10.1.3 and other than cooking appliances as covered in 2.10.2.2. 3. Shall have an ampacity sufficient for the loads served and shall not be smaller than 2.0 square millimeter. Section 2.10.1.3 covers specific purpose branch circuits. As per table 2.10.1.3, electric clothes dryer is not included on the list. Therefore, to determine the minimum ampacity of the conductor for the clothes dryer, shall be the 5,000 volt amperes divided by 230 volts, which gives us 21.74 amperes. According to table 3.10.2.6b16, the suitable conductor size is 5.5 square millimeters. Use 30 amperes for branch circuit protection and 5.5 square millimeter for equipment grounding conductor. Let's move forward with identifying the branch circuit loads and their corresponding conductors, as well as determining the appropriate overcurrent protection and equipment grounding conductors for the remaining appliances. What are the rules for branch circuit sizing for motor load appliance? Article 4.30 covers motors, motor branch circuit and feeder conductors and their protection, motor overload protection, motor control circuits, motor controllers, and motor control centers. The figure shows a motor circuit diagram that can be used as a guide to determine the calculation and sizing of branch circuits, conductors, and short circuit ground fault protection. According to the electrical code, the ampacity and motor ratings required for a given application shall be determined as specified in 4.30.1.6a, b, c, and d when determining the current rating for general motor applications. Subsections A1 and A2 should be referenced. Tables 4.30.14.1 through 4.30.14.4 provide motor full load current values that can be used to determine the ampacity of conductors in motor circuits. The value obtained from the appropriate table should be used to determine the ampacity of motor circuit conductors, the ratings of switches, and the short circuit and ground fault protection required for branch circuits. It is important to note that the value obtained from the table is not the same as the current rating marked on the motor nameplate. What is in Table 4.30.14.1? This is for full load current in amperes for DC motors, while Table 4.30.14.2 is for full load current in amperes, single-phase AC motors. Table 4.30.14.3 is for full load current, two-phase alternating current motors, 4 wires. And for Table 4.30.14.4 is for full load current in amperes, 3-phase AC motors. If the motor horsepower is not listed in the table, interpolation may be used to estimate the appropriate full load current value. Let's have an example. Determine the full load current of the given 10 horsepower motor rated at 460 volts. To determine the load of a 3-phase, 460 volt AC, 10 horsepower motor with an ampere rating that is not available, Table 4.30.14.4 can be used. First, locate the motor horsepower in the left-hand column of the table. Then, find the corresponding full load current value for 460 volts, which is 14 amperes. This value represents the motor load and should be used to calculate the minimum allowable ampacity of the motor circuit. It is important to note that this value is not the same as the 12 amperes shown on the motor nameplate. The first phase in determining the minimum allowable ampacity of motor circuit conductors involves determining the appropriate full load current of the motor. In Section 4.30.2.2 Single Motor, conductors that supply a single motor used in a continuous duty application shall have an ampacity of not less than 125% of the motor full load current rating, as determined by 4.30.1.6a1, or not less than specified in 4.30.2.2a through g. Going back to our project, in branch circuit 15, 1.5 horsepower booster pump, 230 volts, single phase. The first step is to determine the full load current in Table 4.30.14.2 for full load current in amperes, single-phase AC motors, as per table. 1.5 horsepower at 230 volts has a full load current of 10 amperes. Determine the minimum size of the conductor shall be 10 amperes multiplied by 1.25, therefore, the minimum size of the conductor is 12.5 amperes. As per the ampacity table, 2.0 square millimeters is suitable. For branch circuit protection for general appliance motors, the requirement is mentioned in Section 4.30.4. The purpose of the protective device is to safeguard the motor, motor equipment, and the conductor from short circuits or ground faults. However, it does not provide protection against overload. The protective device for motor branch circuit short circuit and ground fault must comply with Sections 4.30.4.2b and c. It should be capable of carrying the motor's starting current. The motor branch circuit conductors must also comply with Section 4.30.2.2. It's important to note that the rating and setting of the protective device should not exceed the value calculated based on the values given in Table 4.30.4.2. Table 4.30.4.2 provides a list of percentages that need to be multiplied against the full load current of the motor, as specified in the electrical code. This multiplication is necessary to determine the maximum allowable overcurrent protection device, OCPD, for the motor. Let's have an example. Determine the short circuit and ground fault protection of a 10 horsepower motor rated at 460 volts, 3-phase. The full load current as per Table 4.30.14.4 is 14 amperes. To determine the short circuit and ground fault protection, as per Table 4.30.4.2, since this is an induction motor, use 250%. Therefore, the short circuit and ground fault protection is 14 multiplied by 2.5 is equal 35 amperes. If the motor branch circuit short circuit and ground fault protective device values derived from Table 4.30.4.2 don't correspond with the standard overcurrent device ratings listed in Section 2.40.1.6a. In that case, you can use the next higher overcurrent device rating. To proceed with the project sample, we need to determine the short circuit and ground fault protection required for a 1.5 horsepower, 230 volts, single-phase booster pump, considering the full load current is 10 amperes. According to Table 4.30.4.2, the multiplier for this case is 250%. Therefore, the maximum allowable overcurrent protective device, OCPD, setting for the booster pump is 25 amperes. How about for air conditioning unit? Article 4.40 of the Philippine Electrical Code applies to electrically driven air conditioning and refrigeration equipment. The rules in this article supplement or modify the rules in Article 4.30 and other relevant articles in the PEC 4.40.1.3a. One important term to understand in this context is rated load current. This refers to the current drawn by the motor compressor when it operates at both rated load and rated voltage. Every manufacturer has the motor for a particular air conditioning or refrigeration unit built according to their specific requirements. The cooling and other characteristics of these motors are distinct from those of non-hermetic motors. As noted, Article 4.40 builds on Article 430. But, depending upon the equipment or occupancy, other articles apply. These are identified in Table 4.40.1.3d. Not all air conditioning and refrigeration equipment motors fall under Article 4.40. Air conditioning and refrigeration equipment that doesn't have hermetic refrigerant motor compressors, such as furnaces with evaporator coils, must comply with, respectively, Article 4.22 for appliances, Article 4.24 for electric space heating, and Article 4.30 for motors. Equipment such as room air conditioners, household refrigerators and freezers, drinking water coolers, and beverage dispensers shall be considered appliances, and the provisions of Article 4.22 shall also apply. Therefore, for room air conditioning unit branch circuit sizing shall apply Article 4.22 appliances. The rules in the code regarding conductors and branch circuit protection for air conditioning units are relatively straightforward. Typically, the manufacturer provides all the necessary details, which are usually displayed on the nameplate rating of the air conditioning unit. However, in cases where the air conditioning unit is not yet available, as in the design stage, for a room air conditioning unit with a 1.5 horsepower motor, 230 volts, and single-phase power supply, we need to determine the conductor size and overcurrent protection device rating. The first step is to determine the full load current, which is 10 amperes according to Table 430.14.2. Next, we need to calculate the minimum conductor ampacity by multiplying the full load current by 1.25, as this is a continuous load. This results in a minimum conductor size of 12.5 amperes, which corresponds to a conductor size of 2.0 square millimeters, according to table ampacity use. For short circuit and ground fault protection, we can refer to Section 4.40.3.2 of the Code. The short circuit and ground fault protective device should not be greater than 175% of the equipment load current rating. If the protective device reaches the 175% threshold but cannot carry the starting current of the motor compressor, the next size larger protective device can be used. However, this protective device cannot exceed 225% of the motor compressor current rating. Therefore, for a 1.5 horsepower air conditioning unit, we can use 15 amperes. If 15 amperes cannot carry starting current, use 20 amperes rated. The procedure for determining the conductor size and overcurrent protection device rating for a 1 horsepower air conditioning unit is the same as that for a 1.5 horsepower unit. However, there is an exception to note in Section 4.40.3.2 of the Code. According to Exception 1, the minimum short circuit and ground fault protection for a 1 horsepower air conditioning unit shall be 15 amperes. This means that the overcurrent protection device rating for a 1 horsepower unit should not be less than 15 amperes, even if the calculation based on equipment load rating and starting current falls below this value. In conclusion, electric ranges shall be calculated based on Table 2.20.3.16 if the rating exceeds 1.75 kilowatts. The branch circuit load for 1 wall-mounted oven or 1 counter-mounted cooking unit shall be the nameplate rating of the appliance. For electric clothes dryers shall be a minimum load of 5,000 volt amperes or the nameplate rating, whichever is the larger. For storage water heater with capacity of 450 liters or less is considered as continuous loads. While for the general motor loads, the full load current ratings listed in Tables 4.30.14.1 through 4 are used to determine conductor ampacity and short circuit and ground fault protection. And for the air conditioning units, the sizing of conductors and overcurrent protection for air conditioning units should be based on the nameplate rating of the unit. Now that we have determined the branch circuit loads, circuit conductors, overcurrent devices, and equipment grounding conductors for all the circuits, we are ready to move on to the next step. In the next video, we will discuss the sizing of feeders and service equipment, which are critical components of any electrical installation. We hope you will join us for that discussion and learn more about the code rules.